You may or may not want to grab a book. I'll leave that up to you. But if you would like to follow along, we are on. We left off with page 85. And as we continue,
I want to use cameras and I have
I believe you.
What is this number?
Oh, Thomas, I really don't like.
Okay, so we'll go over some examples that will aid you, help you, or benefit you, whichever way you want to look at it, in this problem-solving skills or problem-solving sets. So, you feel you need to go over another example on page 85. It was 84 or 85, I can't remember.
85.
Okay. We have all 60 here. The same question did pop up in another class. It said, how big is your chemistry class? I said, 7. I go, oh, actually, the correct is not 7, it's 6. I think a lot of people were surprised by that. That's neither here nor there. Okay, so there are 3 different types of problems that we deal with. It's either changing grams to moles, moles back to grams, or atoms/molecules back to grams. Some of them are 2 steps, some of those are 3 steps. Okay, so as we look at this, let's maybe just quickly look at where we left off with yesterday on page 85. It just says, what is the mass in grams of 0.375 mole of the element potassium? Okay, so we need to begin with a starting number, which is 0.75. 0.375, excuse me. Okay, and all of a sudden, we got a text message or something else, or I don't know, maybe a snapshot, chat, whatever you call it. Or all of a sudden, oh, okay, now we're going to keep on going because we need to cancel that out. What's the problem with it? Why do we need to put the element with it? Well, we don't know if it's 0.375 moles of hydrogen. Is it gold? Is it copper? Is it what? It's potassium, so it's the letter what? Right. Okay, so now as we look at this, we want to cancel out that mole, cancel mole out in the second step. Now, what happens with this, you're not always going to be using a molar mass as grams over moles every time. Because sometimes we're going to see when you start with grams, you're going to be putting it on the bottom. This is what I'm talking about. In this step, we are going to be dealing with grams per mole. Okay? Because remember, we want that mole to cancel out in this step, correct? Okay? So for every mole of potassium, how many grams do we have? I gave you your lightsabers yesterday. Well, I call them lightsabers. Your periodic tables, whatever. Nope. Should be 39, I think. Okay. So 39.10. So remember how we had talked about yesterday, we got our container and we used sulfur as an example. If we had 32.06 grams of sulfur in this container, we have 1 what? Mole. if we put 39.10 grams of potassium in this container, we've got one what? We've got 1 mole. So what that means then, in other words, just don't change anything like I am here. So if we had 1 mole of potassium, we know it's 39.1. Okay. So if we had 2 mole of potassium, we've got pretty close to 80. It's 78.20. So remember, every time you get close to that element's atomic mass, that's how many moles you have. Okay? So if it's over the number of moles that you have, well, then you're going to have twice the number or twice the amount of potassium. If you have 3 moles, my point is you are multiplying them. Okay, so we go back to 0.375. Okay, so what happens to these moles here? Cancel each other out. We're left with what? Grams of potassium, because the question said what's the mass in grams of 0.375 moles? Oh, these two numbers are next to one another. So what do we do with them? We multiply them. Okay? And when you multiply them, you get what?
14.26.
Okay? 14.66 grams of potassium. Okay? And for those of you who maybe take this in college, you'd say, well, we want 4 significant figures because each and every, oops, this one only has 3. Okay? But then you would say that's 14.7. But in this case, significant figures, yes, you sometimes use, but at this level, we're not too concerned about it. We just introduce what it is and what it means. Because what you do is you go by the least number of significant figures in this problem. Okay, which is 3. That's this guy right here. But that's our answer. 14.66 grams of potassium. See, really, I should just cheat. This is nope, not that.
But grams have to cancel themselves out.
See, what am I doing? Why am I working so hard? I should cheat and just use this. Right? This book. So what we're looking at here. Yeah, so there should be 3 numbers. See, 14.7 grams. Okay? But so now we have an idea of how to do these problems. Maybe let's go over another example. Or I should say, are you comfortable with this? Changing the moles to mass. Are we good with that, do you think?
Yes. Yeah.
We just need to go, it's just 2 steps. Okay, so if we turn the page, or excuse me, we don't even have to turn the page. On the bottom of page 85, notice it says how many moles of calcium are in 5 grams of calcium. So notice we went from moles to grams. Who's to say that we would not ever go from grams to moles? sometimes you would do that. So go ahead and pick 1, 2, or 3. 2 is probably the hardest. It would probably be a good practice problem to work on together, just because you're using scientific notation. Number 2 it is. I'm glad you agreed. Okay. How many moles of gold are in 3.60 times 10 to the negative 5th grams of gold? Okay. So the author is saying we're shooting for, remember, 1.83 times 10 to the negative 7. We just pull that number out of the air. Kind of. Okay. So we need to have a place to start. Okay. Now, we are starting with 3.60 times 10 to the negative 5th grams. 3.60 times 10 to the negative 5th. Okay? And that's grams of gold. Okay? One thing that would help you out a lot, does this say anything about starting with atoms or molecules? Are we starting with that? No, we're starting with what? If we're not starting with atoms or molecules, are we looking for atoms or molecules? No. So since we're not starting or looking for atoms or molecules, you will not be using what constant? Avogadro's number. If you see that present, we're starting with this many molecules, or we're looking for this many molecules, then you use Avogadro's number. But it doesn't say that. So we want to know how many moles of gold are in this measurement here. So again, how do we get our grams to cancel in our next step? So if we have grams upstairs, where does grams? Needs to be downstairs. Okay. So then again, when we talk about molar mass, we're talking about grams per what? Grams per mole, or in this case, moles per gram, because what is the atomic mass for gold? 190. Okay, so we're going to go 197. Okay, so every time you have 197 grams of gold, you have one what? You have a mole of gold. Okay, because when we refer to just molar mass in general, it's always considered as grams per mole. That's if you're not looking at anything else. If Mr. Deitch walks up and says, what is a molar mass? Or what is the molar mass of copper? You would say, well, it's 63.55 grams per mole. So where did that number come from? Yeah, periodic table. Okay? So you refer to that every time you get 63.55 grams of that substance, you have one what? 1 mole. So that's why we call it the molar mass. 63.55 grams per mole. Okay? So gold has 197 grams per mole. Okay? But if you're only talking about what is gold's molar mass, that's just one step in this problem. Okay? Notice we do not use grams per mole. We use what instead? Moles per gram. Okay? So since we have a mass at 3.60, we want the grams of gold to be on the bottom, therefore giving us the number of moles. The grams have canceled. Okay. So we're supposed to get somewhere around 1.83 times 10 to the negative 7. Did we get that? Or maybe you haven't tried. Okay. So follow along. You're going to want to punch in 3.60 and then either an EXP button or second double E for that. Chances are it's second double E. Then an E should pop up on your calculator, and that's saying exponent. So what is our scientific notation or exponent in this case? So then you hit -5. Okay? And what mathematical procedure are we doing? Multiplying or dividing? We're dividing. Yep. So then we divide that by 197. And hot darn! What did you get?
0.000000.
Also, we didn't put it inside the notation. Didn't do something like that.
Wait,
So,
2.6. When you got these,
I got
then
this.
you just put
okay, so then you hit -5. Okay, divided by 197.
I got mine too. Just what you get.
Oh.
Yeah. Perfect. I'll show you how to do that, bud.
For some, I don't know why yours isn't. It's still the same answer. Okay, but it's just not reading it in scientific notation.
Yeah, I didn't get
This is Tom.
that.
Tom. Yeah, but you don't want to do it. Tom, hey, my head. There, you're all.
I got 0.0001.
Here.
Yeah, no.
Maybe it just doesn't
This
say
time.
it's for some reason it's not.
Just
Well, then you have to do that.
1.8 to the point.
Okay. So,
Then how do you get
I'm
this?
gonna go on just that. Okay. Here. That means exponent. So we're going to hit that key.
Getting that.
Okay. Now hit not that one. We want the positive. Okay. Yep. And hit to the fifth. Okay. Now divide that.
That's what he got.
197.
9 times?
1.82 times 10 to the negative 7. That's what we want. Okay. Very good.
Oh, but I say -7. Not -7, right?
Yes.
So negative.
Yep.
Got it.
Okay. So this row in the middle is on the bus.
I'm on the bus.
I don't know how to
This
do it.
row is on the bus.
I just have
This
to-
row on the bus. Okay.
Then you can. I do how to
Try
do it.
mode 9.
And Tom, then you do the same thing I did. You hit second button, hit that, and then go to just the first one. Well, there. Yeah, it's just back. You're all-
So for 197.
I don't know if you're right. It's, yeah, it's
So let me
already.
take a peek at this. I'm lazy. Okay. So it looks to me like you, did you punch any of this in here?
No, I'm more.
Okay.
Yeah, I know.
So 3.
I'm gonna try to do this first
0.
one.
So that's how we started it. This is telling you your scientific notation. This is times 10 to the negative 50.
Is this what you got in that second question?
5 times 10. So I'll let you finish this.
I
Your
got
positive,
7.
negative, looks like it's up there. Negative, and then we're going to hit 5. Divide
3.75
that
times
by 197.
36.46.
Oh, I
Did
used
you add-
463. I used 463.
Oh.
So that might be why.
There we go. 1.83 times 10 to the negative 7. That's exactly what we're looking for.
How do we
Did
do
you
it
get this
on
done?
mine?
Ray had that calculator too.
I thought I got it once.
Oh, 90.
Maybe? Is that what you got? Yeah.
So you got for the first one?
Yeah.
Then, yeah. Right, Tom, did you get that one with the Adams yet or not?
Okay. Hydrochloric acid.
Hydrochloric.
Wait, no,
Oh, I see.
I just can't. Wait, what is that? Is that just
Hydrochloride. It's hydrogen and chlorine. Or chlorine. If you add
So like chlorine and hydrogen, you add these.
You add those
Yeah.
together, yes.
Just one each?
Yes.
there's no.
Okay, so hydrogen is 1.01 and chlorine is 30. What is it? 36.45, right?
Yeah.
So 36.
Still looking, still looking.
I've read so many times. This one? I'll go over
Zero.
Maybe I should use my old one.
it.
It's fine, but I have one like that.
Oh, use this one, I can see how you use it on here.
I got
See on this one? Do that, you do add.
Oh,
3.60.
okay. Oh, I was just looking at this. Okay, got it.
I don't know why that's not. I don't see any other one
Oh, I
that
thought
should
it
be
was
scientific notation there, but that's not what it is. Do you have one like Coles?
Yeah, I've been writing this a lot.
Okay, I would highly suggest you use that one. I do not see that that's on here. Other than that, I'm not giving the same answer.
Okay.
Alright, so now the last thing that we want to deal with, okay, and that is changing, starting with a molecule and looking for the number of grams, or starting with grams and changing to that molecule. So, what that means is on page 87. Don't worry, we'll get more practice on these next week. Alright, so as we look at page 87, I want you to look at number 1, number 2, or number 3.
Oh, the practice?
Yes. On page 87, practice problems 1, 2, or 3. Okay. Number 1 says, what is the mass in grams of 7.5 times 10 to the 15th atoms of nickel? So there you see that term, atoms or molecules. So that tells you you will be using what number? Avogadro's number. All right. So as we look at that, we have a starting number, and that is 7.5 times 10 to the 15th. 7.50 times 10 to the 15th. Now, this is grams of, was it aluminum? Nickel. Oh, it's atoms. Atoms of nickel. Okay, so we want to know how many grams are in there. Okay, so how do you suppose we get rid of that atom? You said correctly. You said you need to use what number? Avogadro. That's not a mole. That's number of atoms. it's labeled in atoms, would it go upstairs or downstairs? It goes down on the bottom, okay? Atoms. Oops. Made a classic mistake here. We forgot our Ni, okay? Atoms of, and I put it on the wrong side. Atoms of nickel. Okay, so that's for every one what? For every mole of nickel. Okay, now we're getting closer. Now we're back into this familiar territory. How do we get rid of this mole now? So what's going down here to get rid of it? Moles of what? Moles of nickel. Okay? So then, how many grams of nickel are in a mole of nickel? I wouldn't expect you to know it. I would expect you to know where you can find it.
We're frantically copying this.
You're frantically what?
Copying this.
Oh, okay.
Yeah, I gotta realize we
How many grams of nickel are in a mole of nickel? Okay, so you got that from the periodic table. Yes. 59 point. Okay. That's grams of nickel. Okay. So these are gone. We are supposed to come up with an answer of 7.3 times 10 to the negative 7. See if that's what you get. 7.3.
Do we multiply the two on the top first?
Okay, so remember, if numbers are next to one another, go ahead and multiply these, then divide. Yes, that's what I would do. You got something. Did you get the right answer?
we go from atoms to moles, grams,
Yes.
grams.
Yes.
Or I have to like 7.43 times 10 to the 7?
Yes.
Shit.
That is correct.
I have no idea what it did. So
Oh. You had my calculator.
I did not.
Over.
No, I was using. I know. I figured it all out on my big deal thing.
Okay. I think part of the problem is I skipped a problem set. We could have practiced changing atoms to moles or moles to atoms. I didn't realize I skipped that on page 86. But so we just did an example on page 87. But Is anyone feel like, oh my gosh, this is terrible?
It's not terrible, it's just hard.
Okay?
Okay.
So, one of the things that you can do is go back and watch this video. I'll show you what I mean on page 86. That's my mistake. I should have done this. Very quickly, practice problem number 1. How many moles of lead are in 1.50 times 10 to the 12th atoms of lead? So, what that means, this is just a 2-step problem. 1.50 times 10 to the 12th. Okay, so this is atoms. It wants to know how many moles there are. Okay. So how do we cancel out the atoms in the second step? Right. So do we see some of the similarities here? Okay. So for every Avogadro's number of atoms, you get one what? 1 mole. So this would be moles of lead. So that was just a 2-step problem, then you would be done. So what do you do with these two? You divide them. And you should get 2.49 times 10 to the negative 12. 2.49 times 10 to the negative 12. Okay, that's the problem when we've got short classes like this. Okay. So again, some of the things you can do, you can talk to a senior, you can talk to a classmate, you can talk to myself, or you have this video as a source as well. We'll see you tomorrow.